We're going to look at hash tables now. And hash tables are a data structure that basically allows us to do quick data retrieval using keys. But to understand what a hash table really is, think of it as a dictionary or a map where you can store your data as key value pairs. So you can store your data as this, as you can see here, key and value pairs. So with hash tables, you can quickly find, add, and remove items using a unique identifier or a key. So the key is what we refer to as a unique identifier, and they are commonly used in applications like databases, caching, or even compiler optimizations. So hash table stores data in key value pairs for quick retrieval. That is the main purpose, for quick retrieval. And while we're talking about hash tables, one of the key things we need to talk about as well are hash functions. And a hash function, which you can see here, a hash function is basically at the core of hash tables, and it's like a special formula that takes a key and transforms that key into a number. And we call basically, which you call a hash. The number is what you call a hash, and this number in turn is the one that is going to tell us where to place the data in the table, that is in the hash table. A simple example that we can think of this is, imagine we are storing the word apple in a hash table. So we have apple, and let's say 10 is the number of apples that we have, right? We want to store this in a hash table, and we can basically run it through a hash function. Then it's going to turn into a number. So as you can see here, where we have our apple, then we are running it through a hash function, and it is turning into a number. So it's giving us a hash, right? So this hash tells us where we can store the apple in our table. So at what position we should store. So if it gives us 5, it means we should store it at index 5. So our hash function gets us that index, then we store a value in that index. So in our case here, we're going to take now this apple and its value, which is 10, and we're going to basically store this in our at position 5. So as you can see here, this is position 5, and this is where we're storing our apple and its value of 10. Now, while you're doing this, there are a number of things that can happen. So when you're getting our items, basically we map them through with the hash function, and then it gives us the index. A collision could happen. So, but how we understand this, how this collision would happen, basically is, let's say we have a second item, in this case a banana, and we also pass it through a hash function. So we have our banana here, we pass it through a hash function, and it also gives us the same hash value. So it also maps the banana to index 5. This is now what we call this a collision, right? So we call this a collision. And collisions are normal, they do happen, and our hash tables, they have a strategy that we can use to handle or to address these collisions. And there are two main ways that we can handle this. The first is called, let's actually write it here. First, we can do chaining, and the second method that we can do is what we refer to as open addressing. Chaining and open addressing. And so, for example, talking about chaining, how chaining works is basically we use a list, or in this case, you can use a linked list or any other data structure that you want, but at each index. So if these two items meet at the same spot, so let's say we have two items here. We have apple and we have banana. Banana has a value of 15. So if this is the case where we need to store them on the same spot, basically add them into a list in that index. Yeah. So for example, if we can store all this in a linked list, right? So we have we store all this in a linked list. You can just quickly have some sort of a linked list here. So let's say this is our, we have a linked list. So let's say we have a linked list here, and it has these two items, right? So it has a banana. Let's just to save on time, we can just push. It has the apple there, and it has the banana there. And of course, since it's a linked list, that means that there's a linked like that. And as we know, in linked list, we can also, it's supposed, so if it is a singly linked list, so let's say it has the key and and the data itself, it has the data maybe in this slot here, and here is where we have the link to the next item on the linked list. So if that is the, in a case where we're using chaining, if we use a linked list, so we store, if they share the same address, we basically, or the same index, we store all of them in a linked list like this one, and then we're going to map this linked list to that index, in this case the index of 5. So we basically handle that collision like that. The other method is open addressing. And for open addressing, basically what we do is we go through our hash table, in this case that we have here. It, as you can see, it has a number of slots, and we basically look for the next available position. So if position 5, which we have here, is already taken by the apple, then we might store banana at index. Let's say in the 7, the slot 7 was available, so we'll store it at slot 7. And that is basically what open addressing is. And this process of doing that, we refer to to it as probing. And there are also a number of ways that, when you talk of probing itself, there are a number of methods that you can apply when it comes to open addressing. So that is basically it about hash tables. Just a quick introduction, understanding some of the things that could happen when you're dealing with hash tables, collisions, how you store the elements. Thank you, and I'll see you on the next one.